Welcome everybody. This is now episode 5 in my GCSE revision series. This particular episode will be looking at expansions and collecting like terms. If you would like to see other videos, you can do so just by clicking into the Maths Jedi on YouTube. And a lot of you have been requesting to be able to make comments on YouTube. So this week I'm going to leave the comment line open. So if you want to make comments, please do so in the comments section below the video that you're watching now on YouTube. Otherwise, you can make comments on the chat slide, which is next to the video on Twitch. And if you want to suggest future revision topics, please do so in the comments section. Be nice also, because it's important that I get good comments, good constructive comments, and that'd be really helpful. In case you're new to this, just to remind you, this is for GCSE mathematics only. Anybody revising for the summer. The idea behind these videos is that they're small bite-sized chunks, concentrating upon exam questions really. Nothing from scratch. If you want to do things from scratch, you can do so by looking at lots of other videos which are available on YouTube. But personally, this is just for looking at particular exam questions, just going through some key things. So, as I said, this week we'll be going through expansions and collecting like terms. I just want to show you a couple of things just to remind you about some of the stuff that you'd have been doing in your learning at school. So this particularly is one thing that you might be aware of, the FOIL method. So your teachers might have taught you this. You're looking at how you multiply out pairs of brackets. So particularly pairs of brackets. It's important that you look at the pairs of brackets here. And you're looking at the first two terms. So this term multiplied by this term, that's where the 2x squared comes by. The outside term, so x, and then the 4, and then the inside terms, these two, and then the last two terms, this one and this one. And then obviously you're collecting it all together and writing it out. You may also have learned this particular method, which I'll just show you here real quick, which is the grid method. Again, fairly similar to quite a lot of things that you might learn in maths with regards to multiplication. So you just draw a noughts and crosses grid and multiply out the factors. And you may also have learned other methods as well. So there are lots of methods out there for multiplying out pairs of brackets. The important thing to mention is that you're looking at pairs of brackets and not looking at just single brackets on their own. Single brackets on their own I'll do in just a second. So those two things definitely worth you remembering, knowing. We're also going to go through how you multiply out 3 pairs of brackets today. That particularly for higher students is useful information. So if you're a higher tier student, that will come in handy. I'll do those towards the end of the video. But to start with, I want to go through basic principles, because you'll see that a lot of the basic principles we use are the same as even when you're doing three sets of brackets later on. So if you're a higher tier student, you'll see that the principles I'm using on the first few questions is exactly the same. It doesn't really change all the way through. And so that's why I thought I'd do this particular topic today, because it's quite nice. Get it out of the way, and then you've got some good revision under your belt for the summer. So this question here, you can see we've got a range of questions. Very commonly done is to split questions up and to look at things in 3 different ways. You can see first of all how we've got this question here, which is talking about expanding. This one expanding and simplifying, and this one expanding and simplifying. So you've got these different phrases being used. When they say simplify, they really mean collecting like terms together. So once you multiply out the brackets, you're supposed to simplify, collect all the like terms together. The important thing with looking at pairs of brackets, first of all, is just to multiply numbers on the outside by the characters that you see inside the brackets. You can see here I've got 3x plus 5. Very common misconceptions involve people trying to add these things up, but of course you can't, because this is an x term, that's a number term, so you can't add those two things up. That's a very common misconception. This one, very, very straightforward, just 4 lots of 3, x, which is 12x, so I'll just write that in here, and then 4 lots of 3, which is 4 lots of 5, sorry, which is just 20. So you've got 12x plus 20 there, and then you've got underneath, similarly, you can multiply these pairs of brackets exactly the same way, so 2x minus 8, and then this other one here, 3 lots of x and 3 lots of 5. Just be careful of the signs, that's a common misconception as well, common error. So 2 times minus 4 is minus 8, and then obviously once you get it into this form, you can look to see what's in common. So you've got a couple of x terms here, 2x and 3x. that makes 5x together, so those two things add up. And then minus 8 plus 15, so if it was minus 8 degrees and the temperature rose by 15, what temperature would it be now? And hopefully you understand straight away that is just 5x plus 7. And then underneath here we've got these two pairs of brackets again. So the minute you see pairs of brackets, you're straight into your FOIL method or your lines method or whatever it is that you want to revise. There's several different methods that you can learn. So again, just a reminder where it is. So this is very similar. So we're going to be looking at first two terms. So x times x, which is x squared, and then we do the I'll do the outside terms. So 6x, and then the inside terms 4x. And then the last two terms 24. Again, you can do grid method, or there are other methods. So you can gather together at the end to make x squared plus 10x plus 24. So always spotting that these two are the same. 6x and 4x are the same, obviously, because they're both x terms. This is an x squared term. You can't add these two things together. That's another common error. And you can't add the numbers together because, again, they're different. So all these three phrases different. You end up with x squared plus 10x plus 24 to get your answer, and so that will give you all the marks. This one here, again, very similar. I'm going to show you this real quick, so just get it down there a little bit so you can see it. Yeah, so this one, first of all, is simple collecting like terms, very straightforward, very basic. You're looking at the E terms, first of all, so try to do it in alphabetical order. That seems to be a traditional thing to do, really. So E's before F's, ideally. 2E, and then take away E, so you've got just one E there, we just write E on its own, and then 3F plus the 4F, so that plus and that plus goes with these phrases. The important thing is to associate the symbol with the phrase, so this plus 4F here, and this is plus 3F here. Again, misconception, people often do 3F minus 4F because they see the minus next to it, but that minus is associated with the E term and nothing else. So just important to get that right. So 3F plus 4F is plus 7F. And that gets you there. And then again, another expansion, just like earlier. 5 lots of 2, 10C. And then 5 lots of 3, 15D. Very straightforward. This problem down here was the reason I printed this particular sheet out. This one, a little bit more tricky. So this is saying there are two straight lines, A, B, C, D, E, and P, Q. A lot of people look at this and think, oh, this looks really hard, but it's not that hard really if you think about it, if you're looking at it. This has got a bunch of expressions added up, and this has got an expression of its own. It says in the diagrams, all the lengths are in centimetres. The distance AE, so that's from here to here, is double, so 2 times PQ, so double this. It says find an expression. Notice it says expression in terms of x for the length of DE, so just this bit in here. Give your answer in its simplest form. So let's just look at this in pieces. I always encourage people to think about the things in each line, just decide each line. So we can look at this line first. So AE equals 2PQ. So if we know that PQ is this, which is 3x minus 2, we know that this to here is double that. So we need to do double that distance. So 2 lots of 3x minus 2. And that's just like the stuff we were just doing, expansion. So 6x minus 4. Okay, so 6x minus 4. So you've got the 6x minus 4 here. That's this whole distance from there to there. Now so far we have this expression, this expression, this expression. If you look at what these things are, you've got x, x and 2x. That's 1, 2, 3, 4x. And you've got the plus 3 there, which obviously is a term. You can't add these things up because they're unalike terms. So you've got an x term and a number term. That's 4x plus 3. But we've got 6x minus 4 as the whole lot. So if the whole lot is 6x minus 4, and this from here to here is 4x plus 3, to get this, you just have to do this, take away that. So we're going to do that. We can actually set this out like a sum. Okay, so I'm going to do minus 4, take away 3, that's minus 7, and then 6x minus 4x, that's 2x. And so the answer down here, 2x minus 7. Okay, just show you that real quick. So 2x minus 7 there, centimetres. That's the answer. It's an expression. Did ask for an expression. It's an expression. It's got a mixture of x's and numbers in there. We can't get any more simple than that. That's the answer. That's as simple as it gets. Okay, so here we go into expansion again. So similarly, this is different from the previous examples in that we have an x outside, but you do it exactly the same way. So just x times x, which we know to be x squared, and then x times 2, which we know to be 2x. Okay, so that should hopefully fix that up, no problem. These expansions in here, similar to earlier, so 3y plus 6, so 3 times y, 3 times 2, and then 4x, 4 times minus 1 is minus 4. Again, you can't add these terms because that's a y term and that's an x term, but you can do something about the numbers, the plus 6 and the take away 4. So obviously that's just plus 2, so you get an expression at the end which is 3y plus 4x plus 2. Down here you've got two pairs of brackets, so again you're into your lines method or your for method or your grid method or whatever it is that you use to multiply out brackets. So 2t times t is 2t squared, and then I'll do the outside terms, so 2t plus 5 is plus 10t. The inside terms is 3t, and then the last two terms minus 15. And again, you can look at the t terms, gather those together, so 10t minus 3t is plus 7t, so you've got 2t squared plus 7t minus 15. No problem at all. This one down here is now the reverse situation. They're asking you to do some factorizing. So factorizing is what it says really. You're just trying to look for a factor, a number or a letter that goes into these two phrases. I often call this taking out what's common. So you look at what's common to both particular phrases all the way through, just taking your time and making sure that you're looking at what's common in both particular phrases. So here you can see that there's an 8 and a 12. Now I know that 8 and 12 are both multiples of 4. And I also know that a goes into a squared and a goes into just a. So I can take out 4a as my common factor. So 4a, so 4 goes into 8 and 4 goes into 12, and I can see that they've got a's in common, so I take out an a as common. Now I've got to put a pair of brackets, and I'm going to put inside the brackets what happens if I divide through by this 4a. Let's do the number bit first. So 8 divided by 4 is 2, and then plus 12 divided by 4 is plus 3. Okay, so I know that's how I start these phrases, but then I have to think about what I multiply from a to get to a squared. So what do I multiply by a to get to a squared? Well, I multiply by an a. And then what do I multiply by an a to get to a, which is 1. So that's how we factorize. And we test to see that this works. So 4 times 2 is 8. A times a is a squared. 4 times 3 is 12. A times, well, just itself, just 1 is just a. So that's going to be 12a there at the end. So 3 times 4a is 12a. And so that does work. So you are going to make sure that you check it at the end. If you want to do it in stages, some people like to do it in stages. You can do number bits first and then look at letters second. You'll still get the same answer in the end. It's just easier sometimes to go through it all in one step. So it's slightly easier in one step. But if you want to go through in steps and look at it in bits, you can do. So if you wanted to do that, you could just do the number bits first. So you could take out the 4 as common, and you get 2a squared plus 3a. And then again, you're looking inside the brackets and saying what they got in common. They got an a in common, so you just take the a out, and again you get the same answer, but you've just gone there. It took a bit longer to get there, but it's no problem. You can do it any way you want, as long as you stick around and make sure you get the answer at the end. The last bit, again, this is a quadratic. You can tell because it's got a squared term and another middle term and then a number on its own. And again, you're looking for a factorizer. The minute you see 3 phrases like this, different from the previous example, there was only 2, and there were common things to both. Whereas this one, there are not common things to these 3 things. These 3 things are distinctly different. So you've got y squared, y, and 2. Yes, this is an a squared, but they do have things in common. Yes, these 2 have got in common, but nothing in common with that last term. So the fact that they've got 3 terms, nothing in common for all 3 terms, means this is now sort of trying to get back to a pair of brackets, a pair of brackets that multiply to give you a quadratic phrase. So we're looking for a pair of brackets here, so you have to put your pair of brackets in to work it out. Now, your teacher would have taught you many ways to do this. Basically, you're looking for factors of minus 2. So factors of minus 2 are minus 1 and 2, 1 and minus 2, and I think that's it because it's a prime number, so there's not many numbers that go into these. And then you're looking for the pair of numbers that gives you the middle term. So the middle term is minus 1 here. So minus 1 plus 2 is positive 1, so that's not going to work. But this one works because positive 1 take away 2 is minus 1. So if you find a pair that give you that middle number, the middle coefficients, then you know you're there. So this is just going to be y plus 1 from the plus 1 here, and then y minus 2 from up there. So again, you can multiply up these brackets and test to see that you get this, and you'd have done several lessons on factorising. It's worth your while practicing. I might do a separate video on factorising at some stage, but at the moment I think that'll do for now. But very straightforward, not hard at all. So that brings me on to these now, and I promised earlier I'd look at these more complex problems. So again, this is only suitable if you're doing the higher tier paper. So if you're doing the foundation paper, you can probably stop watching now. This is for those of you that are doing the higher tier paper only. And these crop up a lot now because they're much more common than they used to be. And this is looking at 3 pairs of brackets. You're looking at 3 pairs of brackets being multiplied out. So the principles remain much the same. You've got to start by thinking about your FOIL method from earlier. So again, I'm just flagging that up, the FOIL method from earlier, or your grid method, or your lines method, or whatever you use for multiplying out pairs of brackets. You're going to start in exactly the same way. The important message from my point of view is to try and flag to you that making your life easier is sometimes worthwhile. So you can see in this one, it's not always possible, but in this particular question, you can see that this first set of brackets has a plus in the middle, and this last set of brackets has a plus in the middle. Where mistakes are made is often when you're multiplying by minuses. So I'm going to do just these 2 brackets on either end for now. I'm going to work with those 2 first because I want to try and eliminate any simple mistakes that I might make. So if I look at those 2 for now and take this one to one side, so just ignore the 2x minus 3 for the time being. I'm only taking the positive brackets just because I know that I might make mistakes if I get caught into negatives. But I'm looking at these 2 positive brackets, this one and this one. This is now a pair of brackets which I'm going to multiply using my FOIL method, my grid method, or whatever it is that you want to use. So again, I'm going to multiply this just like I would do any other pair of brackets. So I'm going to ignore this for now, just looking at these 2. So first 2 terms, 3x squared, and then outside terms, and then the middle terms, and then the last 2 terms. So I end up with 3x squared plus 7x plus 2. Okay, so 3x squared plus 7x plus 2. Now, this bracket from earlier, the 2x minus 3, is still there. So what we've got now is we've got to think about how these 2 things multiply out. So we're going to do, it's very simple to do this. This principle's really quick and really simple to do, but you can get yourself in a real muddle. So you've got to be very cautious and careful about how you step through it. So the first thing to do is think about what this is. This is a pair of brackets, and what you've got to do is multiply every single term in this first pair of brackets by this first expression, so this 2x, and then every expression, every part of this first bracket by this term, the minus 3. So we're going to multiply everything here by 2x and everything here by minus 3. And if we do that and collect it all together, that will be now giving us the answer, which is what happens when you expand. And if we collect together like terms, that's a simplifying bit. So we'll multiply everything by 2x first. So I'm going to do that first. So 3x squared times 2x, that's 6x cubed, because an x squared times an x makes x cubed. 7x times 2x, that makes 14x squared, because x times x is x squared. 2 times 2x is 4x. And then I've multiplied every single term there by this term here. I'm just going to double check to make sure I've got the things right. This was going down in reducing powers, so it makes sense this goes down in reducing powers. Now I'm going to multiply everything in here by minus 3. So 3x squared times minus 3 is minus 9x squared. 7x times minus 3 is minus 21x. And then 2 times minus 3 is minus 6. Now, this is where I have to do the simplifying bit. I'm going to collect together all the like terms. So 6x cubed, that's on its own, so I'm going to put that at the beginning. 14x squared minus 9x squared, that's plus 5x squared. And then 4x minus 21x, that's going to be minus 17x. And then you've got just the minus 6 at the end. So you end up with 6x cubed plus 5x squared minus 17x minus 6. And you are done. So this one, exactly the same, but just a bit more complex. This one's slightly more difficult than the previous example because you've got two brackets now that have got minuses in it. You can't really make your life much easier. So I'm going to do the first pair of brackets just exactly as it looks. So these two brackets first. So again, similar method. I'm going to sort of break that up. Think about these two first. So 3x squared, and then I'm going to think about what these things are. So I'm going to slide through that real quick. And then that one. So you've got 3x squared, 14x, and then minus 5. Okay, so then you've got the 3x squared minus 14x minus 5 bit, and then you've got the 4x minus 3 bit. So you have to think now about what is going to happen when you multiply every single term in here by the 4x and every single term in here by the minus 3. So we'll do the 4x bit first. So 3x squared times 4x is 12, do the numbers bit, 3 times 4, and then the x bit, x cubed. And then 14x times 4, okay, that's not straightforward, so we just need to do 14 times 4 to make sure I understand what 14 times 4 is, and you get 56. So 56x, and then minus 5 times 4x is minus 20x. So I've put the squared there, so 14x, 56x squared, and then minus 20x. Again, just double check, x squared, x, no x at all, x cubed, x squared, x. That does make sense. Going down reducing powers of x, reducing powers of x. You always double check that because people tend to forget the square, just like I nearly did. So it's worth checking that. Now we're going to multiply everything by minus 3. So that times minus 3, this times minus 3, this times minus 3. So minus 3 times 3x squared is minus 9x squared. Minus 3 times 14x. Again, just going to be really careful to get this right. So 3 4s are 12, 3 1s are 3, and 1 is 4. So 42x, and then 3 times 5. Well, you've got two negatives. Two negatives make a positive, so be careful of that at the end there, the two negatives. That gives you together a bunch of stuff that you then need to simplify. Remember, we know what we're aiming for here, slightly easier question. So you've got 12x cubed, 56x squared, minus a 9x squared. Does that make 47x squared? Yes, it does. And then 20x minus 42x squared, does that make minus 62x? Yes, it does. And then plus 15. So because this is a show question, just say show up there, we're going to put as proved there, the two lines to say as proved, we've shown it. That's how it works. Just tilt that up so you can see it a bit better. Okay, so that's that one done. And then lastly, again, very simple, similar example, three pairs of brackets again. First two got positive numbers inside of it. That last one, x minus 4, so we're going to break this up, do the two positive ones first. So x squared plus 8x plus 2x plus 16. So x squared plus 10x plus 16 is what happens when you multiply these two up. Just get really good at multiplying up those brackets. It will really help you a lot. And then we've got these two things being multiplied. So again, every single term in here by x, every single term in here by minus 4. That's what you're going to have to do. So you're going to need to do x squared times x is x cubed, 10x times x is 10x squared, 16 times x, 16x. And then everything by minus 4 now. So minus 4x squared, minus 40x, and then minus 4 times 16. I cannot do that in my head, so I'm going to do that up here real quick. 64. So it's minus 64, and then you've got x cubed. 10 minus 4 is plus 6x squared, and then 16x minus 40x is minus 24, isn't it? Yeah, minus 24. So you're going to get that real quick and make sure you've got all of those things in there. So you've got to think about all those little terms that you've got. So you end up with an x cubed term, an x squared term, an x term, and a number term, and that's probably as simple as it gets. Okay. That's the end of this video for expansion and collecting like terms. I hope you enjoyed it. Keep tuning in because I'm going to do loads of these next few days, next few weeks. So hopefully you'll get some good revision under your belt for the summer. If you are revising for the summer, I wish you all the best of luck. If you could leave a like and subscribe, that would be really helpful. If you want to see other videos, please go to the Maths channel the Maths Jedi channel on YouTube, or have a look at me on Twitch. Otherwise, take care for now and hope to see you soon. Bye.